Okay, this is our first video on rational functions, and we want to start by looking at the domain of rational functions. So let's remember what exactly we mean by the domain of a function. When we talk about domains, we are thinking about x values that return a single real function value. So for instance, think about x equal to 1. If we were to replace these x values with 1, then up top we would get a -5, down below we would get 7, and -5 over 7 is a real number, so 1 would be included in our domain. On the other hand, if we thought about x equal to 0, if we plug in 0 on the top, we will get -8. 0 on the bottom is going to give us 0. -8 over 0 is not a real number, and so 0 would not be included in the domain. Now, rational functions are just fraction type functions where the numerator and the denominator are polynomials. Now if we just think about the top part, since it's a polynomial, whatever x value we put in, we are going to get a single real number out. Similarly, the denominator is a polynomial. Whatever x value we put in the denominator, we are going to get a single real number out. So if we just put in any x, we are getting a single real number over a single real number, which is just going to be a real number unless that denominator is equal to 0. So when we talk about the domains of rational functions, we are going to use any x except those that make the bottom equal to 0. So to find the domain, the first step is to figure out where x squared plus 6x is equal to 0. Solving this equation is going to give us the values that we want to throw out of our domain. This one is nicely factorable. We get x is equal to 0, or x is equal to a -6. These are the only real numbers that will not be in the domain because they make the denominator equal to 0. So our domain in interval notation is -∞ to -6, union -6 to 0, union 0 to infinity. Because we use parentheses in this notation, this says exactly every real number except for -6 and 0.